Hello and welcome to another video. This time we're looking at connecting a Wii Nunchuck controller. This controller can measure movement in many different dimensions. It also has two buttons and an analog joystick. To connect this to our i2c bus, a small adapter is available. You plug in your i2c wires and simply connect into the end of the connector. Alternatively, you could just cut off the connector and solder in the wires directly like I have here. If you're interested, the pinouts are as follows. Pin 1 is 3 volts, pin 6 is ground. We then use 2 for the clock and 5 to data. 3 and 4 are not used. So if we run our program, on the display we've got all of the different values that this module can give us. To start with, we've got a joystick at the top, and I can move this left and right and get an analog feedback from it, and up and down. We can also move in this dimension, and this dimension, and up and down. There are also two buttons. The analog joystick gives us feedback on a full scale of 0 to 255. But I've also provided a digital version which we can see at the bottom. This will emulate the same sort of input we get from a standard joystick. So let's take a quick look at the code. It's a very simple project, this one. One of the important things to note is that we've included a Nunchuck library here, and that does all the hard work for us. If we look at that file, we can see some of the functions it provides. There's a call to check whether the Nunchuck is actually connected. There's a call to open the i2c bus, as well as one to close it. There's one to open the connection with the Nunchuck, and this does all the configuration. And finally, there's one which does an update. The update gets the latest data from the Nunchuck device. The data that this library provides is listed below here. There's a value whether the two buttons are pressed or not. There's an analog value of 0 to 255 for the little joystick that's on the top, as well as a digital version, as you saw on the code. And then there's an analog value for each of the different movement directions. We actually receive 6 bytes. The first 2 contain the data for the little joystick. Bytes 2, 3 and 4 contain the information for the movement. They're normally a 10-bit resolution, but these 3 bytes contain the most significant bits. The least significant 2 bits of each of those are in byte 5, together with the button presses. So looking at the code, we do the usual things at the beginning, such as hiding the cursor and clearing the screen. We open the i2c bus, and then we check whether the Nunchuck exists. This will return a value in A of the result of trying to communicate with the device. A result of 0 means everything was fine. So if we don't get 0, we exit. We're then going to open the Nunchuck connection and set up some configuration. We'll print some default information to the screen and then go into a loop. The first thing we do is check if somebody pressed the escape key and exit if they have done. We then call the routine in the library to update the Nunchuck data. And then we're going to display that data. In order to display that data, we're simply stepping through each of those variables we've been given and print them to the screen. Perhaps you can think of a game or an application where an analog joystick would be needed. Or maybe there's a game where multi-dimensional gestures can have an input. If you play my game Escape the Mansion, then the Nintendo Wii Nunchuck controller is already catered for. The analog joystick on the top behaves like a normal joystick and lets you control your character.